All right, let's talk about the invisible magic that makes our digital world, well, work. I'm talking about data compression. It's this unsung hero that lets us do everything from binge watching our favorite shows to sending a million photos from our phones. So, have you ever really thought about this? How does your phone, this little device in your pocket, hold thousands upon thousands of photos? Or how can you just hit play on a movie and it starts streaming instantly, not hours later? It's not just about having a faster internet connection. The real secret sauce is making the data itself smaller. And that, right there, is the whole point of data compression. And why is this such a big deal? Well, because it's the quiet engine running behind the scenes. It makes our internet connections way more efficient. It squeezes more files onto our devices. It makes everything transfer faster. And you know what? It even cuts the costs of shipping all this information all over the world. So what are we actually talking about here? At its heart, data compression is really just the art of saying the same thing with fewer words. Or, in this case, encoding information using fewer bits, fewer ones and zeros than the original. It's all about finding a clever shorthand. Okay, this is where it gets really interesting. See, there isn't just one way to do this. There are actually two completely different approaches, two main schools of thought on how to shrink data, lossless and lossy. Let's dig into that. And this chart shows that fork in the road perfectly. On one side, you've got lossless. This is for stuff where every single bit of information is absolutely critical. Think text documents or computer code. And on the other side, you've got lossy, which is what we use for media like images, video, and audio, where perfect isn't always necessary. Okay, so what's the real difference here? Think of lossless like a perfect vacuum-sealed bag. You suck all the air out to make it smaller, but when you open it back up, everything inside is exactly as you left it, perfect. Lossy, on the other hand, is kind of like writing a summary of a book. You're going to leave out some details, right, to get the main point across? And that's the key. With lossy, that lost data is gone for good. But here's the clever part. It's not just any data. It's the stuff our eyes and ears probably wouldn't have noticed anyway. And what's cool about this is how it lines up with things we do every single day. When you create a zip file, you're using lossless compression. I mean, you definitely want your spreadsheet to come out exactly the same on the other end, right? But every time you snap a photo with your phone or stream a song, you're using lossy compression to get a file that's small and easy to handle. All right, so we've covered the what and the why. Now for the fun part. Let's take a little peek under the hood and see how these things actually work their magic, starting with a really simple lossless method. So just imagine you had to write this down. It's a lot. Super repetitive. You've got these long runs of the same letter over and over. This is exactly the kind of pattern that lossless compression just loves to find. And here's the beautifully simple fix. Instead of writing B 9 times, then A 16 times, and so on, the compressed version just says B9, A16, N1, M10. See? It's the exact same information, but it's said in a much shorter, much more efficient way. And when you decompress it, it comes back perfectly. And that's really the textbook definition of run-length encoding right there. It's a simple idea, but it's super powerful, and it's a basic building block for a lot of compression. Find a pattern, and then just describe the pattern instead of repeating it. Okay, let's jump over to the lossy side of things and talk about probably the most famous format of all, the JPEG. Now, this isn't about finding simple patterns. This is all about human perception. It's a system designed from the ground up to throw away the information our eyes aren't very good at seeing anyway. So how does a JPEG do its thing? It's a really smart 4-step dance. First, it chops the image up into tiny 8x8 pixel squares. Then comes some clever math. It transforms those pixels, separating out the big, broad strokes of color from the super fine, tiny details, kind of like splitting the bass from the treble in a song. Now, step 3, this is the crucial one. This is the lossy step. It's called quantization, and it basically gets really aggressive with those fine details, the stuff our eyes aren't great at seeing anyway, and it either simplifies them way down or just deletes them. Poof. That's where the data gets lost forever. And finally, whatever's left over gets neatly packaged up and saved as that much, much smaller JPEG file. And all of this leads us to the biggest challenge in the world of data compression, especially on the lossy side. It's this constant balancing act, this trade-off between quality and file size. Yeah, this picture of the sunflower just says it all, doesn't it? The original file is massive. Lossless makes it a little smaller, no problem. But look at what Lossy can do. You can shrink the file size dramatically, But if you go too far, you start to see those blocky, ugly bits. That's the trade-off, right there in front of you. Let's actually put some numbers on that. The original image is 738 kilobytes. Not huge, but not small. Lossless gets it down to 630 KB, a nice little savings. But a good lossy compression, it gets it all the way down to 147 KB. That's less than a quarter of the original size. And honestly, for most uses, you'd barely notice the difference. That is a huge win for efficiency. So really, the next time you're watching a movie on Netflix, or listening to a Spotify playlist, or just texting a photo to a friend, remember that this whole process is happening instantly, in the background. Billions of calculations by algorithms with names like MPG, MP3, and JPEG, all working nonstop to squeeze data down so it gets to you fast. So what's the big takeaway here? It's that data compression isn't just some techie thing for nerds. It is the invisible engine that makes our entire modern world go round. It's constantly making these tiny decisions, balancing perfect quality against the practical need to just get things done. And that leaves us with a pretty big question for the future, right? We're creating more data now than ever before, and it's only speeding up. So what's the answer? Do we just keep building bigger hard drives and faster networks? Or will the real solution be even smarter, more clever compression algorithms that can shrink our digital universe down even smaller? It's something to think about. Thanks for joining me for this explainer.